Now we are getting from microphone level, and when this microphone level crosses 0, when it's from negative becomes positive, we start counting. So we turn on counter, and then we start counting until the event when it crosses 0 again. So now we have number of clock cycles of 50 megahertz clock. Okay? And because we know the frequency of the clock, we can simply multiply this 50 megahertz by number of clock cycles, and we can figure out how many clock cycles is, so what is the frequency of this node. And then we use lookup table to tell what node this is. So easy, and everything is in hardware. Okay? Now, this is the way how to recognize sound without any software, just using configurable hardware. Now in the same way we can actually synthesize sound. We just need to produce this sinus wave. So now our second component generates sound. So now I can do node synthesizer, and I can do synthesize for FPGA. And now we can create a electronic piano implemented in hardware only. Okay? Second. Now, like I will show you actually how schematics is generated. It takes some time for synthesis. Oh, see sound. Okay, now. So okay, so this is how we generate sound. Now let me show you what kind of schematics is generated from this code. So let's get for example node recognizer, and let's actually choose different FPGA board because that board shows us better. So let's get board D2-115, which is 23. Yeah, so you can actually insert here microphone and just test whether it still works. Yeah, this is the way how we are going to test microphones. But now let me show you how code becomes schematics. Okay, so we are now run GUI for FPGA synthesis. So this is Altera FPGA synthesis. So here is our code. So here is board specific. Okay, first we need to synthesize it here. It will take some time. Okay, so this is code in system verilog, and you can see how it recognizes sound. So it has register like previous microphone level, and like every time on the positive clock, when clock goes from 0 to 1, we get a previous level of microphone. And now check that if left bit is if previous value is 1, and it became 0, so it was negative and becomes positive. Then we put 0 to counter, and we put to the variable distance value of the counter, and like all other time we are just counting. Okay. Now, when we have this distance, we are using some code just to compare it against values from Wikipedia. So we have frequencies from Wikipedia, and we just compare against some frequencies, and this is how we figure out the note. And now we can also put finite state machine and recognize melodies. So this is kind of basic idea. Now you can see the schematics. So if you click to like netlist viewers, you can see RTL viewer, and you can see that this code actually becomes schematics, and you can click here and look down to the gates. So this is like previous microphone level, and this is schematics for the block which gets serial data and converts into parallel data. Now, yeah, I will check. Yeah, nine more.
Need to go.
Okay, this
Can help you some other day.
Good, thank you.
Yeah.
Huh?
Can help you other day.
Okay, thank you. We can, yeah. Okay, so now the next step after this code is converted into such logical structure, the next step is a technology map viewer. So then this code is mapped into a specific cells for this specific FPGA. So like originally it's just like abstract graph, and now it's mapped into cells of this FPGA. Okay, and finally there is another viewer which is called chip planner, and in chip planner it actually shows the cells in FPGA configured with this code. Okay, here. You see, so it goes like to the cell level.
А это автоматически.
Да, это значит автоматический tool, который делает place and route. Automatic place and route. So like it gets code, it converts code into a graph of logic element and memory elements, then it places and puts routing connections.
No.
Yeah, completely automatically. And then it puts configuration memory of this chip, so we can see this like digital circuit running, like recognizing sound and producing sound.
I have a question.
Uh-huh.
I'm surprised that this simple approach with just measuring the distance between crossing zero works, because I would expect that sound has lots of like harmonics.
Yes. We do have. Okay. First of all, even if you do harmonics, basically you still have.
Yeah, you still show
if you do harmonics, you still have something like this, and this doesn't cross zero. But not only that, we also do little bit of filtering. So we are doing some crude filter. Second, we are mostly using flute to make sound, and flute sound is very clear.
Okay.
Yeah. Now, apparently it can recognize my singing, but usually I use flute to make the sound. Now, like this code do have filtering. So if you go here, it basically checks that this node was stable for some time.
Okay.
And this code for filtering is here, so node filtering. So we check this is stable. And after we check, we just put this to 7-segment display. And that's it.
Do you also check for multiples so that it can be in different, like different octaves?
Basically difference in frequency in different octaves is 2 types. So like so like I have code here which actually checks whether frequency is multiplied by 2 and multiplied by 4. So it has like 3 octaves range. Yeah. So this is what we do with those microphones. Okay. Yeah, I have a presentation which I usually show on those events, and the presentation how like generally chip design. And so usually when I go to places like Azerbaijan, I show them this presentation. Then for 1 week to do some like exercises with the FPGA boards. Yeah, so now we can do same thing in like Uzbekistan, maybe in Mexico, maybe like in other places. This is how like I spend my vacations. So just like going to like other countries and making such seminars. Yeah, so you see, the good thing is that with such FPGA exercises on FPGA boards, you can actually train people who do ASICs, and there are even open source tools right now. Yeah, so this is and like those kids from mathematical school number 57 in Zelenograd, like some of them, so they learn about CPU core design.
57-я школа? 57-я школа и Гарвард PhD, да.
Да, но правда, вот, в общем, короче, да, но вот этот парень работает в компании Syntacor, дизайнером процессора. Вот, да, в общем, вот, да, но они не все с 57-й школы, только типа трое, но из разных других школ. Вот. Ну, вот все такая теория, вот это элементы этого кода. Да, so one difference between this and software engineering is that you have a propagation delay. So basically in hardware things do not happen instantaneously, you have a propagation delay. So you need to create logic which fits clock cycle. And in order to make any like complicated behavior, you need to build like finite state machines, pipelines, and so on based on state elements. So and here like I'm talking about the state elements and the general like notion of hardware with finite state machines connected with like artificial intelligence, with like a Chinese room, which is effectively a state machine, and that kind of stuff. So I can talk about this in many details if you are curious, because I'm like talking about this on such like verilogу meetups all the time when new people are coming. So yeah, but there are such books, and book on the left can be used from scratch. So like I just gave a book to one of like people who came recently, so they can like read it. But like generally, if you start from this book, you can learn basics of digital hardware design. Yeah, this book is like a little bit more complicated. This book is used in MIT and Stanford, but this book still doesn't go to the modern industrial level, unfortunately. It goes approximately to like state of the art of year 2000. And because like it goes to skid buffers, but modern industry people use instead gradient-based flow control. So there is book published in Cambridge recently, which actually go to this level, but they don't have examples. So we are now discussing on those verilogу meetups, those both like introductory and task sort of job interview level. So this kind of activity. All right. So any questions about that?
Yes. What do you suggest, like, where do we start with all of that?
if you want to start, I have actually, first of all, you can come here on a regular basis. This is one thing. Second thing, so you can have a page which is called self-education and educating others. And this page has complete instruction what to read, what to how to as a list of projects. Yeah. So basically, if you put a lot of efforts in it, you can go to the very good level in a year or two. Yeah, and so if you put a lot of efforts, you can pass a job interview for a year. Because most of US and worldwide students, they actually don't go to the level of type of very long tasks we are doing here. So if you ask them during job interview to write this recognition of sound, which is actually a very simple problem. This problem more than half if you do it okay. Yeah, but if you ask them something about pipelining and flow control, which is very frequent task in industrial setting, like everywhere, Apple, Nvidia, Samsung, and so on, many of them simply don't get enough practice to pass those questions. Yeah, so basically, to be honest, I think that they spend 4 to 6 years in college very inefficiently, because they spend hundreds of $1,000s and they cannot pass tasks which can be taught in a month or two. And so now, but this is only basic level, so many of them do not practice enough for basic level. But there is more advanced level, yeah, but there is a minority of students who actually do this, the rest of them, yeah. So if you are curious about this thing, you can just follow this link and get this book. I have actually Russian translation, I was editor of Russian translation of earlier version of this book, when it was MIPS edition. So now it has RISC 5 edition. I recommend this edition, but there is a Russian translation which is free. And yeah, so you can just I can send you link. You can just download it and start reading. But you need to read in this book really first few chapters a little bit, and then to read chapter 4, which actually teaches how to code in a hardware description language. Yeah, well, so then I have some homework tasks. So I have